Welcome to the Center for Automotive Research. We have for 3 decades now focused on education of engineering students in the field of automotive engineering and also work to serve industry and government agencies to provide innovative technology solutions to make the future of transportation cleaner, safer, more efficient.
CAR is housed in a 56,000 square foot complex on Ohio State's West Campus. Our facilities are a key enabler to supporting our work in both innovative research and providing world-class education.
The subject area of our research is any improvement and innovation in technology that will increase the safety and security of our vehicles, their energy efficiency, diminish their environmental impact, and generally speaking, make them more intelligent.
Our first grouping of labs includes our engine and powertrain research. This is made up of 4 powertrain test cells, including engine dynamometers, electric machine and power electronics test benches, as well as a combustion and turbo machinery laboratory. Next, we have our full vehicle testing labs, which includes a light-duty chassis dynamometer for passenger cars, as well as a heavy-duty chassis dynamometer sized for bus and truck research. We have an extensive battery testing facility that includes a cell characterization lab for cycling and aging battery cells, and also a module and pack validation lab that scales all the way up to full-size bus and truck battery pack sizing. The battery facilities also include a prototyping and welding facility, and we also partner with facilities across the campus, including our Nanotech West facility and materials corridor, to do development on the chemistry and at the cell level.
As our society is quickly transitioning towards electric vehicles, we're working closely with government agencies and industry to improve batteries' efficiency, durability, charging speed, safety, and cost. Our team has expertise in every aspect of battery research and development, including material synthesis, modeling simulation, and then characterization analysis, systems integration and control from cell to battery pack to prototyping in vehicles.
CAR also features a software and hardware-in-the-loop control system development laboratory. This laboratory supports the development of vehicle control systems, battery management systems, and we even have expanded to do hardware-in-the-loop hybrid electric aircraft simulation.
We are leveraging the lesson learned from ground vehicle electrification to support NASA and Air Force and the industry in developing concept of advanced air mobility. This includes electrification of propulsion systems for commercial aviation and urban air mobility.
Here at CAR, my research group focuses on developing new methods to control and optimize vehicles and smart buildings, making them more efficient and sustainable. These systems are complex, non-linear, have many interactive components, so controlling them and optimizing them is challenging from a both theoretical and practical standpoint.
Here at CAR, we have the Driving Dynamics Laboratory. In this laboratory, we're able to model real-world conditions, looking at vehicle dynamics, ADAS systems, and autonomy, and put a driver in the loop driving in mapped real-world conditions as well as virtual conditions. CAR's newest lab is our cybersecurity facility. This has the laboratory component where we can work with various electronics components on the vehicle and assess cyber threats. I'm also very excited to announce that we have emerging labs coming to support our work for the Federal Transit Administration, and we'll be having a much larger focus on full vehicle and component testing for medium and heavy-duty vehicles.
With funding from the US Department of Energy's Next Car program, CAR, along with industry partners TRC and Borg-Warner, are researching innovative ways to minimize the energy consumption in connected and automated vehicles.
With the ramp-up of vehicle electrification, we need more infrastructure available for charging. OSU CAR is involved in research that is looking at mitigating the impact of uncoordinated charging events on the grid by leveraging distributed energy resources and smart vehicle operation.
Thanks to funding and collaboration with our industry partners like the Ford Motor Company and Stellantis, and funding from the National Science Foundation, the Department of Energy, and ARPA-E, we aim to reduce the environmental impact of the transportation sector and the built environment through a system-level multidisciplinary approach.
Connect Community project is a large demonstration program, and we are looking at utilizing building flexibility to support grid services. At the time of a critical need, OSU can reduce the electrical power request from the grid and get remunerated for this power reduction.
Carbon Plus is composed of a consortium that includes North Carolina A&T, the University of Texas at Austin, and the University of California, Irvine, and is led by the Ohio State University. At Carbon Plus, we are looking at developing concrete, testable, and scalable solutions for reducing transportation cybersecurity risks, especially as we move to the era of autonomous vehicles, whether they are ground vehicles, aerial vehicles, or maritime vehicles.
The Ohio State University, as a land-grant institution, has as its primary mission the education of the citizens of the state of Ohio. We engage over 100 graduate students who pursue the research that will lead to their master's thesis and PhD dissertations. In addition to that, we provide, through our student projects, an opportunity for experiential education where more than 300 undergraduate students every year become engaged in design, build, test, validate, and demonstrate projects related to advanced technology vehicles that often are part of national or sometimes international competitions.
The Ohio State Student Projects Program includes the Baja Buckeyes, Buckeye Current, Ohio State EcoCar, Formula Buckeyes, Buckeye Auto Drive, and Buckeye Solar Racing, and the world's fastest electric vehicle, the Venturi Buckeye Bullet. Students gain experience with designing, fabrication, racing, managing, and marketing competition vehicles. This experience includes machining, engine testing, battery testing, and computer-aided design. In addition, team members also work closely with industry partners, developing valuable connections that often roll over into career opportunities.
We are very proud to say that the outreach program at CAR is flourishing. In the last year, we engaged with more than 7,100 individuals and conducted more than 150 events, including tours, camps, and internships. From our students to our staff to our faculty, we are passionate about sharing our love of innovative mobility engineering and inspiring future engineers to take us to the next level in moving people and goods safely through our communities.
So finally, I would like to thank all of the sponsors who make it possible for our students to pursue graduate studies and do fascinating projects, for providing the resources that allow us to educate the next generation of automotive engineers. And thank you for watching this video. We look forward to having many more productive interactions with you in the future.